class, so I thought I would record a video of me working another problem that we've been working in class. And so here's just another example. This is probably a very complex problem because I'm dealing with 4 different moving parts. And so let me just show you how to work it. So first off, it says a gas has a pressure of 14.7 psi. And so that 14.7 is telling me the initial pressure. And so down here I'm just going to type 14.7 psi. And so then it tells me that it's 20 degrees Celsius over here. Okay? So then that would be the initial temperature. However, there's a problem with that. Celsius degrees, we know, is not directly or inversely proportional with anything because it's in Celsius degree. The whole reason Kelvin exists, the Kelvin scale exists, is so that it can be directly proportional with volume and pressure. And so therefore I need to make it in Kelvin by simply adding 273 to it. So 273 plus 20 is 293 Kelvin. So that's my initial temperature. Then it says that the gas has 15 units of air. So that's talking about the number of particles, and so that's 15 units. Then finally it tells me that initially I have a volume of 555 milliliters. And so that's my initial conditions. Then it says the gas is changed to the following conditions. 20 psi, so that'd be my final pressure. 40 degrees Celsius. Oh, and then I've got to add 20 to it, so 273 plus 40 would be 313 Kelvin. And then we've got 5 units of air. That's talking about our number of particles. And so now the question is, we do not know what the volume is, so that's what we're solving for. So this is a pretty complex problem because I've got 3 things changing, and I'm trying to figure out what the new volume would be. And so let's take this one step at a time. So the first thing we're going to look at is pressure. So the question is, what happens to the pressure? Well, I can see that it's going from 14.7 to 20 psi, so therefore I know that it's increasing. So now the question is, if pressure increases, what effect would that have on the volume? Well, I know that pressure and volume are inversely proportional. That's what Boyle's law states. And so because they are inversely proportional, I know that if the pressure increases, then volume is going to be decreasing by the same amount. And so therefore, if I insert my problem that I'm going to solve, I know I'm going to take the 555 milliliters of the gas with the volume, and I'm going to multiply that by a ratio of the pressures. And so then I just simply need to define what ratio I'm talking about. So in this case, since I'm predicting a decrease in the volume because of the pressure, I would want to take the 14.7 over the 20 because I'm predicting a decrease. So whenever I'm predicting a decrease, I want to make sure that the smaller number goes on top, the bigger number goes on bottom. So that would be 14.7 over 20 psi. And so now that is, I could go ahead and calculate that, and then I can move on to the next. However, I'm just going to show this all together so that it can be all done in one IFE table. And so if I multiplied that, I'd get a new volume, and I would be decreasing that volume. And I know that would be correct because I'm predicting a decrease. So now let's look at what's happening to the temperature. Well, it's going from 293 to 313 Kelvin. And so therefore I know that it is increasing. So now the question is, what is the relationship between temperature and volume? Well, I know that because temperature, I know that if I heat up the particles are, the volume of a gas is going to want to expand. So therefore I know that they are directly proportional. Oops. For some reason I'm having some hard times copying, but let me just go insert here, and I'll just insert another up arrow. So I'll just show that that is increasing, and that is increasing because the temperature is increasing. So I'm even going to change the color here to make sure that I know that because the temperature is increasing, the volume is also going to increase. So therefore, what I've done down here is this has counted thus far in the parentheses. I've accounted for the pressure. but the temperature is going to cause an increase because of the directly proportional relationship. And so therefore, I'm going to multiply this by a ratio of my temperatures now. So now the temperature that I want to multiply it by should be the bigger number over the smaller number or the smaller number over the bigger number. Well, if I'm predicting an increase, which I am, I would want to go the bigger number over the smaller number. So therefore I go 313 Kelvin over 293 Kelvin. So now the final one that we got is the number of particles. And so the number of particles that we got, it is clearly decreasing. It's decreasing. So therefore I'm going to show a downward arrow. And I'm going to change the color again. I'll make it green. Now the question is, if I decrease the number of particles, what effect would that have on the volume? Well, if I think about holding pressure and temperature constant, this is not a law that we talked about. But if I think about that, if I decrease the number of particles, what that means is the volume of the gas has to shrink. And so therefore, I'm going to go insert, and I'm going to insert a new shape showing to where that is pointing down. And so the number of particles decrease, that should cause a decrease in the volume. And again, I'll change the color to match that. So the greens line up. So therefore, when I come down here, thus far I've accounted right here, in this part right here, I've accounted for the pressure, and I multiplied that 14.7 over 20 because of the predicted decrease. The temperature says, oh, that's going to increase, so therefore I multiplied that by a larger number over a smaller number. And then I'm going to account for the number of particle change. And the way I'll do that is, because the number of particles decrease, I'm going to predict a decrease here. So put that over there. And so then I'd want to take 5 units over 15 units. So then let me reposition my arrows now where they line up. So here's my basic equation of multiplication. I see this is predicting a decrease. Notice small over big. This is predicting an increase. Big over small. This is predicting a decrease. Small over big. And so now it's just a matter of multiplying that all together and dividing it. And so then in my calculator, I would take 555 times 14.7 times 313. Oh, I could go divided. Let's go divided. So back to the drawing board. 555 times 14.7 divided by 20 times 313 divided by 293 times 5 divided by 15. And my final answer should be 145.3. Nope, I don't know where I'm typing that. My final answer should be equal to 145.3, and that should be units of milliliters. Now I do need to write that in proper significant figures, and so I come back up here. 14.7, that has 3, 20.0, that has 3, 15, that has 3, 555, that has 3, 20.0 has 3, here's my limiting one, 40, that only has 1, and so therefore I need to round 145.3 to 1 sig fig. So I start counting 1, and then that's a 4 that follows it, so therefore that should only be 100 milliliters. And so that, folks, is my final answer. Hope it helps.